Hi there, this is Penelope. This is a short video on using integration to find the area between two curves. This is a follow-on from finding the area underneath a curve. So we have here two curves, and what you've got to do is show that the two curves intersect to form two closed loops, so that one of them's there and the other one is there, and to find the area of each loop. Now you could also be asked to find the area of the total, in which case you just add them together from the amounts that we find. The difficulty in this problem lies in appreciating the problem rather than the integration itself. It's impossible to begin until you've got a picture of what's going on. So I've drawn the picture there, and you can see that there's a green bit and a goldy bit, but we can't find the areas of those two bits until we find where the curves intersect. So we need to do that to start off with. So the two curves, x squared times 2 minus x, must be equal to x times 3 minus 2x. So either x equals 0, which is it's quite clear from the diagram, or x times 2 minus x equals 3 minus 2x. Rearranging that gives that 0 is equal to x squared minus 4x plus 3, and that could be factorized, or you could use the quadratic formula. So that'll give us that our 3x intercepts are 0, the first one that we found, 1 and 3. Now to find the actual y values, we substitute in to the original, and we find that the points are 0, 0, 1, 1, and 3, -9. So now we've got the points where the two curves meet. So this one's 3, -9. That one there is obviously 0, 0. And that one up there is 1, 1. Now, once we've got those points, now we can integrate and find the area of the separate bits. So if we call this green one A and the gold coloured one B, then to find area A, it's going to be the integral from 0 to 1. Now, what we need to do is we probably need to label the curves. If we call the parabola y2 and we call the cubic y1, then the area A is underneath the parabola and on top of the cubic. So the area required would be y2 minus y1. So the integral between 1 and 0 of 3x minus 2x squared minus x squared, and it was 2 minus x. Before you can do anything, you better do all the algebra. And what have we got? 3x minus 2x squared minus 2x squared plus x cubed. So tidying that up and then integrating it at the same time, we get x to the 4 over 4, that's from the last term, minus 4 over 3 x cubed plus, integrating the first one, 3 over 2x plus c, and number crunching there, 5 over 12 square units. Similarly, to find area B, it's the other way round. It's the integral between 1 and 3 of y1 minus y2, because remember you have the top function first. So that would be the integral of negative x cubed plus 4x squared minus 3x. And once you've integrated that, I might run out of room, negative a quarter x to the 4 plus 4 over 3x cubed minus 3 over 2x squared, and we're going to evaluate that between 3 and 1. And using your calculator, or your brain, 132 over 12, which would be 11 square units. In the second example, it says find the area between the x-axis, the ordinates. Now, the ordinates just mean the x value. And the x values in this case are pi by 4, pi by 3, and the curve y equals the cotangent of x. Now, this one is perhaps a little easier to understand, but the integration process is a little more complicated. So the area is going to be the integral between pi over 3, pi over 4 of cotangent x. And if you use your tables, that's the natural log of sine x between the limits. So that would be the natural log of sine pi by 3 minus the natural log of sine pi by 4. And if you remember back to topic 5 where we're talking about logs, you could simplify that as being sine pi by 3 over sine pi by 4. Whichever way you do it, you should get that it's approximately 0.203 to 3 significant figures. The last example has got quite a lot of information in it simply because it was a bit tricky. You needed to work out a whole lot of stuff that was a bit hard. It's a horn-shaped loudspeaker, so it's kind of, there's your exponential function, so you can see like that. It's giving you a round function like that, and that is 60, and from 0 in there, so it's not actually that bit. Okay, find the volume of the air inside the horn. Okay, we've got that K is approximately, whoops the daisy, K is what we've got, and also we've been given the information that e to the 60k is 16. So using the volume formula, you'll be given this. Okay, so it's from 0 to 60 of 1.5 e to the kx, and the formula says we have to square that. So taking the pi out, leaving the pi out, 0 to 60. Actually, we could take out the 1.5 squared as well. And then we've got to integrate e to the 2kx. Okay, that would be e to the 2kx over 2k from 0 to 60. Now just be careful. You tend to assume that if you're going to put 0 into something, it's 0, but a 0 into an exponential function gives you 1, not 0. Okay, so we're going to put in 60, so that would be e to the 120k minus e to the 0 over 2 times, and we're told what k is, 0.0462. Okay, a little bit of smarts here. We need to figure out, given the information that we've got, that it needs to be pi times 1.5 squared times e to the 60k squared minus the 1, because e to the 0 is 1. So I factorise that. Now I know that e to the 60k is 16, so all I have to do then is square 16, put it in the calculator, minus the 1, do all the rest, and we get that it's approximately equal to 19507.45438 cubic inches. But it would be more sensible probably to put it into cubic feet, so you need to divide by 12 by 12 by 12, because it's 12 inches in a foot, and then it would be in cubic feet. Okay, you're not likely to get one in feet, but America is in feet, so good to know.